All right, folks. Hey, it's Mr. Pilcher from the spare bedroom once again because he's stuck at home with COVID. So crazy. Quarantine's the worst. Well, anyway, so, all right, it's Tuesday now. So let's recap the week schedule again. Same slide as yesterday. So we have lectures today and yesterday, Monday and Tuesday. Tomorrow, on Wednesday, Miss Pepperly will be back. She's a substitute you guys had a couple times last week. She taught Chem at North for a really long time. You are going to have a quiz tomorrow over the stuff that you learned today, okay? So if you're honors students, that quiz tomorrow will include stock system as well as what we learned today. For you regular chem students in my 7th and 8th period and 10th period, we'll just have that quiz over what we learned today in class. Okay, so now when you come in tomorrow, Ms. Pepperly is going to help you guys do some review on formula weight and percent composition. That's what we're learning today. And then you'll take that quiz the second half of the class period, okay? So we're going to learn today formula weight and percent composition, then practice. Tomorrow you're going to come in, practice some more, and then you'll take a quiz with Ms. Pepperly, okay? Now on Thursday, there'll be another lecture video. It's over balancing equations. This is a big one. You really don't want to miss that one because balancing equations can be kind of confusing. It's pretty weird. But we're going to have to do it a lot in Unit 6 and a lot in Unit 7. So you want to make sure you really understand what's going on there. And then I, your boy, will be back on Friday. Very excited. So that is the deal for this week. Now let's go ahead and jump into things. So you guys should have a notes handout that the sub gave you guys at the beginning of the period. So we're going to go ahead. You'll need your periodic table and a calculator for this one. And again, all the stuff that we're about to learn today will be on the quiz tomorrow, okay, with Miss Pepperly. Now, first thing we got to do is let's look at a handful of these compound formulas here. Now, you should be able to name all these already, okay, because of the polyatomic blue sheet, okay, the blue polyatomic ion sheet. So this guy, NaHCO3, oh, there's a little squeak, a little cat went underneath my chair here. It's my cat Bing. He's feeling really needy. I need to go teach chem, buddy, okay? All right, here you go. Plop. I'm sure a bunch of people are just like, "Aw, oh my gosh, he's so cute." Buddy, leave me. You hear a jingle in the background. That's just him. Anyways, so we need to count how many atoms of each element are present in these compounds. Okay, so for this first one, NaHCO3, also known as sodium bicarbonate, if you're using your blue polyatomic ion sheet, has 1 sodium, 1 hydrogen, 1 carbon, and 3 oxygens. Okay, so remember, that little subscript at the end here, this 3 only applies to what's right before it, which would be the oxygen in this case. And so we have 3 oxygens. Over here, Na2SO4, that would be sodium sulfate with an ATE at the end. Again, blue polyatomic ion sheet helped us there. We got a couple of sodiums, 1 sulfur, and 4 oxygens. So should be pretty straightforward so far. These next two can get a little goofy. So SrNO32, this is strontium nitrate. Notice how we had to put the whole nitrate in parentheses because we needed more than one of them, because the nitrate's only got a charge of -1, and it's going with the strontium. It's got that charge of +2. So this is a review. We should already know this. Now, there are a couple of ways that you can go about doing this, okay? So you can sort of draw out the visual if you want. So what this would really break into is you have the 1 strontium with a +2 charge, and then 2 nitrates like this, okay? Or you can also, if you want, you can sort of use this 2 and distribute it. So 2 times the 1 nitrogen in there, 2 times the 3 oxygens in there. Okay, you can multiply that 2 by everything inside the parentheses. The bottom line is we are going to have, whichever method you use, we're going to have the 1 strontium. Now, how many nitrogens? Well, there's 1 nitrogen in each nitrate. And since we have 2 nitrates, we're going to have 2 total nitrogens. And lastly, with those oxygens, again, there's 3 in every nitrate, but we only have 2 nitrates, and so 2 times 3 is going to get us 6 total oxygens. Over here with this aluminum sulfate, we got the 2 aluminums. A little off there. Move this up. The sulfurs, so there are 3 total sulfurs, okay, because there's 1 in every sulfate. We have 3 of those sulfates. Sulfate's SO4. And 3 times 4 is going to give us those 12 oxygens. It's really important that you can be able to count how many atoms of each element are present for what we're about to do next with formula weight. So what is formula weight, Mr. Pilcher? And this is where you'll need that periodic table so very badly, okay, unless you want to memorize all the masses listed on it. So formula weight is the total mass, the total, grand total, so we're going to do a lot of addition here, of all the elements in a compound. So you're going to take the mass of all the elements in a compound, you're going to smash them all together in one big pot, and that's what your formula weight is. Okay, now to calculate formula weight, there's a couple of steps. First, you have to find the element mass. So the element mass is the number of atoms of any given element times the mass found on the periodic table. And we are going to use whole numbers when it comes to this. Okay, we're going to use whole numbers of the periodic table, so round to the closest whole number. So, for example, okay, on your periodic table, if memory serves me right, so if you look at chlorine, element number 17, okay, your periodic table will tell you that its mass is like 35.45, okay? Now, we're not going to use that value. We're just going to round to the closest whole number. So what is that 0.4 after the 5 tells us to do? It tells us to round that 5 down. So this is really just 35 for chlorine. And there's a bunch of other examples. So like oxygen's listed on your table is like 15.99, I think. But we're just going to call that a clean 16. Or like hydrogen's listed as like 1.00 something. We're just going to call that 1, so on and so forth. Okay, so you can just use whole numbers on this. Make your life a lot easier and simpler that way. Now, formula weight is when we're going to add up all the element masses into one total pot, okay? All the element masses in one total pot. And you may be a little confused in what I'm saying here, but let's just do a couple example problems and I think you'll get the hang of it. Okay, so this first compound we have is water, just a little H2O for you, your favorite, okay? So how many hydrogens are there? Well, there are 2 hydrogens and 1 oxygen. So that first step is just what we did up here, okay? Now, what is the mass of a hydrogen on your periodic table? Well, if you go to your periodic table, you'll find that the mass of a hydrogen is just over 1. It's like 1.00, something like I mentioned earlier. So we're just going to call that a 1. And oxygen is like 15.99. We're just going to call that an even 16, okay? So now we have 2 hydrogens times their mass of 1, which gives us an element mass for hydrogen of 2. We have 1 oxygen times the element mass of 16. So that gives a total of 16. And we're going to add these 2 up. 2 plus 16 is 18. And you don't have to have that number memorized, but you're going to calculate the formula weight of water like a million times. And eventually you'll probably get to the point where you're just like, oh, it's 18. I remember it's 18. Kind of like the 4.18 deal from Unit 3, Thermochem. Great memories. Let's try a little bit more complicated one. Let's try the sodium sulfate here. So again, we have 2 sodiums, 1 sulfur, and 4 oxygens. And notice how clean my work is. It's super organized. I have everything labeled. I make it really hard to make a mistake. And even if I did, it'd be pretty easy to catch it as long as I'm really organized. The students who always do the best on this quiz coming up are the ones who are just super organized. Their work is really clean cut. Now the mass, rounded to the closest whole number of element number 11, sodium, is 23. It's listed as like 22.9 something, but we're just going to call that 23. So 2 times that 23 will give us a total mass of 40, or element mass of 46 for sodium. Sulfur is coming in at 32. 1 sulfur times its mass of 32 gives us 32 over here. And oxygen is coming at 16. 4 atoms times 16 for each one because the mass is 64. And if you add all those up at the end, our formula weight is going to be 142. So formula weight doesn't really involve anything more than just kind of simple counting, addition, and multiplication. It's just that there are so many steps that you have a lot of opportunities to make a mistake if you're not really careful and you're really organized, okay? Because it's not like you guys can't count to 4, you can't round a number of 15.99 to 16. It's just you want to be really careful, super organized. That's what we're looking for. Now, there's kind of one more piece to this puzzle, okay? We got to talk about percent composition. Percent composition. Now, in order to get percent composition, you always have to calculate the formula weight first. So when I ask you to do a percent composition problem on your quiz tomorrow, you'll always have to calculate the formula weight first. And no matter what, you can always get a little partial credit just by calculating the formula weight of something because you know that's where you need to begin. So percent composition is the mass percent of each element in a compound. So you're going to find what percent each element contributes in a given compound. So the first thing you got to do is you got to get that formula weight. And then here's how you get the percent composition for any given element. You take that element's mass, You divide it by the formula weight, which is the grand total, and you multiply that by 100% to make it a percent. Now, if we go back to this problem we already did right here. So we have water, okay, H2O. So we're going to calculate our formula weight first. So we got those two hydrogens. They each have a mass of 1. And that gives us an element mass for hydrogen. Hydrogen's element mass here would be 2. For oxygen, we have 1 oxygen, mass of 16 for each one. And oxygen's element mass will be 16. Okay. Now, our formula weight will come out to be 18, because 2 plus 16 equals 18. Now, here's what we're going to do. If we want to find the percent composition of hydrogen, we're going to go ahead. We're going to take that 2 and divide by 18. So the element mass is 2. Divide that by 18 and find that this is about 11% hydrogen. You can round to the closest whole number there, because I know it comes out to be 11.11 something. And with oxygen, you're going to take that 16 divided by 18. So we're both divided by that same formula weight and multiply by 100. And you'll find that oxygen comes out to be 88%. And actually, that shouldn't say 88. That should say 89 if we're rounding to the closest whole number, because it's 88.88 repeating, I want to say. And so there you go. Now, these two numbers should basically always add up to 100%. Okay, so 11 plus 89, if you want to double check yourself at the end, does add up to 100%, and we are good to go. So that brings us to this worksheet right here. So if you are my substitute teacher, if you wouldn't mind hitting pause real quick to hand out this worksheet. Now, let's go ahead and try one of these practice problems. So first one, it says, go ahead and get me the percent composition. The percent composition for all the elements in the following compounds. So, all right, so we want the percent composition of copper and bromine, and copper 2 bromide, or copper bromide. So how will you do that? Well, we need to first get the formula weight. So we have 1 copper, 2 bromines. Every copper rounded to the closest whole number comes out to have a mass of 64. So we have an elemental mass of 64 for coppers. The bromines come out to be an 80. It's like 79.9 something. We're just going to call that 80. So 2 bromine atoms times their 80 gives us an element mass of 160. You add those 2 up, and there's your formula weight. So if this problem asked you for the formula weight, and that's it, you would just end right here. So in tomorrow's quiz, a couple of problems are just going to ask you for the formula weight. You don't need to go any further than this. This is your final answer right here. Okay? Whoopsie. This is your final answer right here. Now, if I ask you for the percent composition, though, you do need to do one more step. Okay? So we're going to take the elemental mass of copper, which is 64. We're going to divide it by the formula weight, which is 224. Okay? If we multiply that number by 100%, you'll find that this is about 28.6% copper. Now, down here with our bromine, we're going to take the 160 contributed by bromine, divide it by the 224 of the formula weight, and find that we're looking at 71.4% bromine. In other words, copper bromide is 28.6% copper and 71.4% bromine by mass. And yes, these two numbers, if you add them up, the 28.6 and 71.4, they do come out to be 100%, which makes perfect sense. The last thing that I forgot to mention earlier, I'm coming back over here, with formula weight, one thing I want to say is that formula weight, some of you guys will be happy about this, does not have no units. There are no units for formula weight, okay? So if I ask you, no units, which is a little crazy because I'm always a real heckler for you guys putting units on everything. So if I ask you, hey, what's the formula weight for copper bromide, and you just tell me 224, we're good. I'm not going to be like 224 what? Miles, minutes, seconds, kilometers? I'm not going to do that to you like I normally would. This is like the one exception to this rule, so you don't have to worry about putting units on here. You can just put 224 as your final answer. Of course, the model student would box it up. All right, so you guys have the rest of this worksheet. The answer keys should be around the room, so you can kind of do a couple, check a couple. There will be a quiz on this tomorrow, but just remember, Miss Pefferly will be there tomorrow. She can answer any of your questions because she taught chemistry forever at North. And you guys will do a lot of practice the first half of the class tomorrow before you take that quiz. So lots of opportunities to practice right now and also the first half tomorrow before you take that quiz. Please let me know if you have any questions. I will see you guys next time.